In this last one, I want to show an example of where you can prove an identity and not always necessarily follow our rule of turning everything into sines and cosines. So because I see both cosecant and cotangent on both sides of this thing, I'm a little less apt to go ahead and convert everything to sine and cosine. And this is a case where I might actually make it harder. So here, we'll start with the left-hand side. And this would be a good one to look over at the right-hand side and see what's there. So right now I see that I have a cosecant plus 1. So without worrying too much about what's happening otherwise in the denominator, let's go ahead and just make that show up. But of course, if you're going to do that, you got to do that on top as well. Oops. Cosecant is what I mean to write. All right, so on bottom, I'm not in a hurry to try to multiply anything out, but on top, I am going to multiply that out, right? And the reason I'm not multiplying on bottom is I'm kind of hoping that the cotangent's able to get canceled somehow. And since right now I can't see a way for that to happen on top, that's why I'm multiplying the top out. But what I see is this is a difference of squares, right? This will be the cosine squared theta minus 1. All right, now this should look familiar. This is one of our Pythagorean identities that involve cotangent and cosecant. So it turns out that this is equal to the cotangent squared theta. Now, that one's probably a little bit less on the tip of our brain. So remember that if you see this, you should suspect that maybe it's a Pythagorean identity. And so remember, the way to check what the others are is you start with the one we definitely have memorized, and then you divide everything by whatever's necessary to produce the ones you're interested in. So cosecant would be 1 over the sine, so I'm going to divide by sine squared everywhere. So that gives me a 1 here, a cotangent squared here, and a cosecant squared here. And then, of course, subtracting 1 from both sides gives me the identity I was hoping I could use. But then, of course, I can cancel out that cotangent on the bottom with one of the cotangents on top. And so I'm left with exactly what the right-hand side says.